Okay, so in this part of the lesson, we are now going to look at properties of circuits, circuit symbols, types of circuits, and electricity analogies. So, in order to draw a circuit, it would be really cumbersome if we always had to draw out all the parts of the circuit like we saw in the last lesson, and we had to actually draw a light bulb, a battery, wires, and so on. So scientists created symbols so that it made it easier to communicate the parts of a circuit. So let's look at the different parts of a circuit and their functions. So first we have a wire, which is simply a straight line. And the function of a wire is to connect components in a circuit so that electrons can flow through them. Secondly, we have a cell or a battery. One cell is shown here. One cell is equal to 1.5 volts, and this is a source of energy that generates electric current by chemical reactions, like we saw before. And this is our symbol. So to draw this, we drew this before, you simply must short line and a long line. This is your negative and your positive terminal. Make sure if you can't draw a straight line, use a ruler. Thirdly, we have a light bulb. So here's a symbol for a light bulb. Here's another one, which is just as fine. And this represents a load in the circuit, and it's used to change electrical energy into light energy. Below this, we have a resistor, and a resistor is used to decrease current by a specific amount. It's also another type of load. So to draw this, we would just simply, it doesn't have to be this exact many lines, as long as I'm going to do it like this, look. Okay? That's completely fine. Doesn't have to be perfect. As long as I get the idea that it's a resistor, that's fine. This is an open switch. So when I draw an open switch, it doesn't have to be little open circles like that. You can draw it just like that. And this controls the circuit, controls the electricity. Below that is a closed switch. So in essence, it's just a line with two little circles on it. And again, if the circuit is closed, the circuit will work. If the circuit is open, the circuit will not work. We also have an ammeter. And an ammeter measures current in a circuit. Let's just say circle with an A in it. I will show you how to draw circuits and how we put the ammeter in. We would add it in series with the circuit, which you don't know what that means yet, but you will soon. And a voltmeter is a circle with a V in it, and this measures the potential difference or voltage in a circuit of a battery. And this is written in parallel, which we'll talk about soon. And oftentimes, so you would show this over a device. Let's say I want to find the potential difference of a battery or cells. So this would be that, and I would draw my little voltmeter on top. That means I'm finding the potential difference of of those cells. Okay? This is a fuse. Looks kind of like an S. So down and up is fine. There you go. And we place that before a cell or battery, and it's a safety device used in a circuit used to protect the circuit from overload. Maybe you've seen them in your house or in devices. We often say we've blown a fuse, but now it's a circuit breaker, but fuses are in many devices to protect them from overload. And a circuit with an M in it is a motor, another type of load in a circuit used to change electrical energy into motion. So we will have some practice of drawing some of these in actual circuits in class. The two types of circuits we will draw are a series and a parallel circuit. So in a series circuit, there is only one path along which electrons can flow. The electrons flow in one direction from the negative to the positive terminal. So here's a picture of a series circuit. So we see that the electrons are flowing. This is the negative terminal, this is the positive terminal, and they're going to flow this way around the circuit. So an analogy for a series circuit are like race cars driving along or traveling along a racetrack. So, you know, here's your racetrack. Okay, so if there's cars on it, they only have one way to go. Yeah, I'm not really good at driving in cars, so there's my little car, beep beep, okay? My car is gonna whiz around, it can only go on this track. So this lends to the properties of series circuits. So if one bulb burns out, the current will stop. All the current goes through all of the bulbs. Now the more bulbs you add in series, the lower the current. I will explain that when we do our lab, and we will see with the circuit how that works. You cannot just turn off one of the loads. It's an all or nothing situation. So because the current is going through all of them, it's the same, and as soon as I cut it off, the current doesn't go to any of them. Another type of circuit we will look at are called parallel circuits. Parallel lines, right? So the bulbs are on parallel lines. Oops. Parallel. They're on parallel lines, as you see. So there are two or more paths for the electrons to flow. So this analogy are like cars driving through a city block. So I could show you the city block. Let's make it like this and around, and show you if you've driven around your town, or you could see that this would be a city block. So here's my little car, my terrible little car. So my car could go here, my car could go there, my car could go there. So multiple paths for the car to travel. The electrons have multiple paths here. So here they have multiple paths. So the electrons are coming this way. They could choose to go this way, or this way, or this way. So if one bulb goes out, let's say this bulb here in the middle goes out, there are still two other paths for the electrons to flow. So the current leaves the source and it splits up. It goes down this way, and that way. So the more bulbs are added, the brightness does not change. This is how our Christmas lights. So our Christmas lights are wired in parallel. They used to be in series, and then one would burn out and the whole string would burn out, and you would never be able to figure out which one was the burnt out one. You'd have to play with them and try each one, and it just was such a hassle. So it's so much better now that they are in parallel. So another perk is you can turn off just one of the loads, and this is how our homes are wired in parallel. Thank goodness, right? Because if you turned off one light, everything would go out in your house if it was in series. So that's a little bit about the types of circuits we will see and circuit symbols. The last part of this lesson is looking at some of values that we will talk about in this unit. And we're going to compare it to water. So why? Because current flows just like electricity. So we often talk about water when we talk about electricity, just so we can understand it. So electric charge is the charge on a given number of electrons, and the unit we use for that is called a coulomb. And this is equal to the analogy of a number of water droplets. So that is what charge would be. And the current is the number of charges that move past a point in a given amount of time. And we measure current with an ammeter. The unit of measurement is an ampere. And this would be the number of water droplets moving past a point. So we see, obviously, we're going to have a lot more water droplets going past this point, going past through this tube as opposed to this one, because this is a wider one. So this would have a higher current because just more water droplets could flow. So the next value we're going to look at is potential difference. Potential difference is also known as voltage, and the unit is V, the volt. So this is the amount of energy in a given amount of electrons, and we measure this with a voltmeter. So we could compare voltage or potential difference, its potential, to the height, which is like energy, potential and a position, energy of position, the height from which the water falls. So you could just think to yourself, think about a waterfall, think about Niagara Falls, and think about a Little Falls. Think about how fast and the amount of pressure that comes from Niagara Falls. So the farther it's falling, the more amount of energy given to the electrons. So that is potential difference. Lastly, we're going to look at resistance, electrical resistance. And just like resistance, the word resistance says to you, to resist, to prevent, to stop. It is the property of a substance that hinders the electric current and converts electrical energy to other forms. We will spend more time talking about resistance in another section, but if you think about electrical energy and how hot a lot of your appliances are, that's because the electrical energy is being wasted and not being converted into the intended use. So it's being resisted. So the unit for resistance is an ohm. And we can liken resistance to, if you think about in our example of the water tank again. So the water tank now has equal sizes of tubes coming out of it, but this one's going straight down with no resistance, and this one has little bars in between to slow the water down. So slow it down. That's what it's doing, slows down the current. That's called resistance. So what are some factors that affect resistance? If you think about wires and think about what could affect resistance and impede electricity from flowing through, the first thing is the material. So we know that metals are conductors, so wires have to be made of metals. But there are all different types of metals that have different types of resistances. But overall, they're all pretty good, but they vary in price. So this is why we don't have all of our metals made of, our wires made of gold or platinum. They're just very expensive. So all of them tend to be good, and metals need to be what wires are made of. Now, temperature is something that will slow down the flow of our electrons. Why? Because everything's moving so quickly, and that it's just hard for the electrons to get through. Imagine, you can think about this like, imagine you are at a school dance and there's lots of people, and or actually a concert, maybe you've been to one of those, and you're trying to get through general admission where there's lots of people. So there's lots of resistance, really hard for you to get through. It's warm and people are dancing and it's hard to get through. So that's kind of a good analogy for resistance. Higher temperature, higher resistance. Length. A longer wire gives more resistance. Kind of makes sense, right? I mean, if you think about, if you think about two wires, one is short, one is long, it's obviously going to take electricity more time to get through a longer wire. And lastly, cross-sectional area. So this would be thickness or thinness of a wire. So again, think about space, a lot more space, so there's less resistance for the electricity to get through. So that's a little bit about factors that affect resistance. So in our next lesson, we are going to learn how to draw circuit diagrams. That's all for now.